Welcome to this explainer. Today, we're cutting straight through the noise to look at the actual, raw mechanics of global warming. We're going to focus purely on the hard data from NASA, the EPA, and the IPCC to figure out exactly how our planet regulates its temperature and, well, what happens when that natural balance breaks down.
Right off the bat, let's tackle a really fascinating contradiction. How can something that literally keeps our planet alive also be causing a global crisis? I mean, we hear the term greenhouse effect thrown around in the news constantly, right? And it's almost always framed as this big, bad, negative force. But the truth is, the greenhouse effect is a completely natural, absolutely essential planetary process. So how did a life-saving feature of Earth become the main driver of global warming?
So here's the crucial thing about greenhouse gases. Things like carbon dioxide, methane, water vapor, they inherently do an amazing job making Earth a Goldilocks planet. When energy from the sun reaches us, these gases act exactly like a cozy blanket wrapped around our world. They trap just enough heat near the surface to maintain a really comfortable global average temperature of 15 degrees Celsius, or about 59 degrees Fahrenheit. It's not too hot, not too cold, it's just right for life to thrive.
It's actually kind of wild to think about just how dependent we are on this system. NASA points out that if you were to magically remove all the carbon dioxide, the natural greenhouse effect would literally collapse. Earth's surface temperature would plummet by 33 degrees Celsius. Our incredibly lush, beautiful blue planet would turn into a freezing, uninhabitable wasteland. So, yeah, we absolutely need this blanket.
The problem
brings us
isn't
to
the blanket itself. We've established we literally need it to survive. The problem is that human activities are piling on extra layers. By burning fossil fuels, running massive global agricultural systems, and managing huge landfills, we are effectively taking a perfectly balanced bed and throwing thick, heavy, totally unneeded blankets right on top of it.
And I really want to pause and highlight one absolutely crazy outlier in the EPA data: fluorinated gases, or F-gases. These are entirely synthetic. They have virtually zero natural sources. They act as these insane super insulators. Get this, they have a global warming potential up to 23,500 times greater than carbon dioxide, and they can just linger in the atmosphere for thousands of years. In the US alone, emissions of these hyperpotent gases shot up 105% between 1990 and 2022.
If you want the ultimate receipt for this imbalance, take a look at the famous Keeling curve. This data has been continuously measured at the Mauna Loa Observatory since 1958, and it gives us a really stark visual of how carbon dioxide has rapidly accumulated. We started at 313 parts per million back then, and today, it's an unbroken, relentless climb past 406. And those little zigzags you see along the way, that's actually just the Earth breathing, as plants grow and die off with the seasons, all while riding that massive upward trend. To translate that curve into sheer volume, the IPCC estimates that in 2019 alone, human-caused greenhouse gas emissions hit 59 gigatons of carbon dioxide equivalent. 59 gigatons! It's almost hard to wrap your head around a number that massive. We're essentially wrapping the Earth in thicker and thicker insulation at a rapidly accelerating pace.
Because of this staggering volume of gas, the scientific consensus leaves zero room for ambiguity. The IPCC states unequivocally that human activities, principally through greenhouse gas emissions, have caused global warming. The extra blankets are doing exactly what you'd expect blankets to do. They're trapping the heat.
So what is the actual measurement of that trapped heat? Well, all those extra greenhouse gases have brought global surface temperatures up by 1.1 degrees Celsius compared to pre-industrial levels. To put that in perspective, global surface temperatures have increased faster since 1970 than in any other 50-year period over at least the last 2,000 years.
We're watching the physical consequences of this unfold in real time. Global air temperatures are up more than 2 degrees Fahrenheit over the past century. And that extra energy in the system, it acts like fuel. It supercharges heat waves, causes incredibly severe, prolonged droughts in some regions, and drives catastrophic, intense flooding in others due to shifting rainfall patterns.
And man, the oceans are really taking a massive hit here. As they absorb all that extra heat from the atmosphere, two compounding things happen. First, warming water physically expands. It literally takes up more volume. Then, you combine that physical expansion with trillions of gallons of brand new water pouring in from melting land ice. The result is rapidly rising sea levels that are threatening coastlines all over the world. So, let's bring it all together. We know exactly how the greenhouse effect works. It's a beautifully natural phenomenon that makes our planet livable, a perfect Goldilocks zone.
But we also have the undeniable, heavily measured data proving that human activities are adding immensely powerful extra layers to that blanket. We've tipped the scales, and we are overheating our home. The science is incredibly clear, the mechanism is totally understood, and the imbalance has been mapped out. So the only real question left for us is, how quickly and how decisively will we act to restore that balance?